Hi, everyone. Thank you so much for joining today's webinar. Today, we are talking about cold chain, the latest and greatest in supply chain technology in the cold chain market. My name is Natalie. I am going to be moderating the questions today. So if you look at your screen on the right-hand side, you will see the Q&A box. Please type your questions in there. We only have 30 minutes today, and we're really focusing on dialogue. So please, throughout the entire session, type in your questions. Our speaker will be reading them out loud and pushing them to the screen. Again, thank you for joining. Our presenter today is Tom Swoboc. He is our resident expert at Dematic on everything cold chain. His title is Market Development Director, and his job is really to forecast what we should be doing as a technology provider in the cold chain market. So with that, I will hand it off to Tom. Thank you again.
Hello, everybody. Tom Swoboc here. Thanks for joining today. And yeah, we'll talk today a little bit about cold chain. And let me share my screen. And I believe right there, we'll get us going there. And okay, let's see. Today I'll talk a little bit about how big brands are saving money and the planet in cold chain. And the really, when we think about that, we're thinking about people, product, and planet, I should say. And those are the things that's referred to as triple bottom line. And certainly those are the things we want to focus on when we think about our cold chain efforts and automation in cold chain. So I want to start talking first about what I'll call the wheel of needs. So people, they're your lifeblood, and they're fundamental to your business. The good ones are priceless, and good work environments allow them and your business to grow. Then space. Space is a finite sort of thing. It costs money to buy, and in cold chain, it costs even more money to maintain. So we want to be good stewards of space, and ultimately want to satisfy our customers' demands. Our customers are why we're in business, but they're also in a competitive world. They have high expectations of you, and are frequently applying a lot of pressure to your organization. It's obviously important to be able to satisfy their needs. Ultimately, these three needs really align very closely to that people, profit, or planet and profit I talked about a few minutes ago. Now, how do we solving these needs is certainly the lifeblood of your business. And some of the mechatronics tools that we'll use to be able to do that are techniques of storing of cases and boxes, building pallets, storing pallets, and transporting. That's somehow you can be doing some one or more of those functions. And we'll talk a little bit about each of those today. So in some of your business, your product is stored in cases prior to becoming pallets. That is destined for customers. And then occasionally actually being what we call each pick business, where you're actually picking individual pieces out of a box to be able to assemble an order for a customer. Building pallets. Sometimes that's straightforward. Sometimes you have product coming from production and you're going to build a single SKU pallet. And sometimes building pallets isn't so straightforward. Maybe you have a complex flow coming from production, or maybe you have a complex multi-SKU pallet shipping to customers. And then lastly, you've got storing of pallets. That's pretty fundamental to all of our businesses today. That's how everything pretty much gets shipped, and that's pretty much how it gets stored in a warehouse. There's a lot of different choices that we have as far as how to configure pallet storage warehouse. But when we think about the number of days on hand of inventory we have, what our SKU complexity is, what our lot sizes are, and what kind of tracking is required, all those elements together really go into, what is best. So what we'll talk about today are really three different types of solutions. One's for pallet systems, another for case picking and palletizing, and the third of which we'll touch on is each picking. Now, as we start talking about storing and picking of cases and or boxes and pieces, the objective here is let's use as little labor as possible and have that labor that you do need to apply to be as productive as possible. We certainly want to be those good stewards of space, ultimately, and then think about this in the context of how do we maximize our customer satisfaction. One of the tools that we have to be able to do this is something we call multi-shuttle. And what we see here is a system with a lift in the front in many different levels. Boxes or totes will be picked up and then moved to a storage position, or occasionally even moved to an adjacent aisle position, then picked up out of the rack, and then moved to an outbound position to be sent to either a shipping or palletizing or a picking process. We also may have, as I alluded to earlier, an each pick type process where we're maybe building a customer order of multiple different SKUs that'll get packed into a box. This is a goods to person type configuration. There's also, or person to goods, I should say. Goods to person is another configuration that might exist. But in this instance, it's paperless picking, and the number of pieces to be picked would read out on a display shown there. And what we'll see is an example of such a system in motion where that display told the people how many to pick. We'll frequently have some sort of system monitoring so that this automation can be monitored throughout the day to make sure all the pieces and parts are working correctly. Within such a system, you're looking at transporting of product on conveyor through multiple levels. And there we see the display that I talked about just a few seconds ago. And here you start to see a fairly efficient use of space. We can certainly store products quite a bit higher than what was shown in this particular layout. In this case, the height was limited by the customer's building as opposed to the capabilities of the technology. But in addition to being used in the fashion we talked here, we can also use the shuttle to sequence product out for case picking. So as opposed to each pick, we could feed product out for an exact sequence. Here's an example of a case pick operation using that same shuttle, and a series of lanes down the side, each one corresponding to an individual order, such that if we have a whole bunch of different SKUs, and some of those are relatively slow movers, they take a long time to pick if they're spread across your warehouse. So the faster movers, which there's a lot more of on a pallet, we may build manually and then bring the pallet over to one of these lanes, do a top off, and make that quite a bit more efficient. This is a technique that's pretty common within the food service space. When it comes to building pallets and ways of trying to do that automatically, we're going to look today at a couple different robotic approaches. Once again, we want to try to minimize our labor requirements and maximize our customer satisfaction. So a product is going to come either from production or for some kind of buffer, come to a palletizer, and output either to a warehouse or to shipping. So palletizing can exist in quite a few different places within a warehouse. We're going to look quickly at a few different approaches, one of which is what we'll call a star robot. That's a robot that can palletize up to 8 different products simultaneously. This is typically going to be associated with a manufacturing type operation. Pork, for example, where we have a lot of heavy boxes, may be a use case where this would be quite applicable. Second type is what we're thinking call a ring robot. This is likewise primarily suitable for a manufacturing process where we're going to have a random flow of products coming in from manufacturing or production, and we want to create a single SKU outbound. So as things come in a random order, we get the robot sets them in a rack temporarily, and then when the output is required, pulls out of the rack and sends downstream either to some sort of manual or automated palletizing process. And lastly, we have a situation where we'll couple a shuttle along with a single arm robot to be able to build some sort of complex pallet that'll frequently be used in protein manufacturing and or some sort of automated order fulfillment. You'll get a handout as a result of attending this, and on there you'll see this chart in there which starts explaining where these different types of palletizing approaches work best. But ultimately, still another choice you might have if you want to improve your productivity, but just move into automation in an incremental fashion. We have a solution called ErgoPal that provides the product to the operator in an ergonomic or in a very simple fashion. So they're sliding as opposed to lifting. Has the operator work at a quite high rate without really ever doing any lifting. Now, granted, this picture, either that person is really tough or this was in a dry environment. I think it was dry, but this is also suitable for chill and frozen applications as well. And then lastly, let's think about storage of pallets. The same things apply, right? We want to use labor as effectively as possible. We want to be efficient in how we use space and want to make sure that we're using the technology to really help maximize the satisfaction to our customer. We're looked at fixed automation solutions today. And the first of which we'll talk about is a crane-based ASRS. That's what we traditionally have thought about from an ASRS. Very high density, can go to heights up to 140 feet, and very high selectivity. So it works well where you don't have a lot of land available, but you do have height available. I would advise that system, you would like to have a plot of land that's comparatively long relative to wide. So long aisles certainly work quite well. And here we'll just watch a video that shows one of these in operation. What we have shown here today is a beverage operation. So this isn't to apply that it's cold chain, but the same technology works in a cold chain environment. I shared this one just because there's a breadth of different functionalities that are shown here. In addition to the ASRS, we have automatic trailer unload. So product comes in, is automatically unloaded from a truck and moved into the ASRS where you'll see it stored in a moment. When it's required to be put on an order, it's extracted, brought out. And what we're seeing here is a staging lane. This is a technique that can be used to stage outbound orders in a very specific sequence, such that when a truck backs up to the dock can immediately be loaded. You can do dock turns as fast as 20 minutes using such an approach. Benefits there, of course, is when you have high rates of dock turns, you don't need as many dock doors, you don't need as many dock doors, you don't have as many leaky dock doors, and once again, that becomes a kind of a planet-friendly kind of approach to things. Another technology to think about from being good use of space is what we call a 2S pallet shuttle. This is a newer technology than the crane-based ASRS. It's very high density, heights up to 70 feet. Its use case is very high throughput and comparatively large lots. Here we see a little bit of technology. This is one of our partners that we'll work with for these types of solutions. That same solutions, we call it a 2S, others might call it a mother and child. As you can see here, the technology is very adaptable to lots of different building type configurations, and as such is quite suitable to brownfield type applications. And consistent with this audience is quite suitable for deep freeze warehouse as well. Yeah, so we see the pallet being conveyed up and then onto the shuttle and stored away. And a first cousin of 2S pallet shuttle is 4S pallet shuttle. High density as well, and similar heights, suitable for high throughput, not quite as high as what the 2S may do, but it can tolerate smaller lot sizes and still be effective. But its huge claim to fame is its scalability, its ability to be able to adapt to lots of different layouts, and can have a high degree of configurability. So here we'll see the shuttle in motion. What you'll notice is there is no longer two different devices. There's one device that works in two different directions. And these devices can go onto a lift. So as such, part of the scalability is you don't even have to, when you first put the system in, have devices on each level. But you can expand those as your system throughputs might grow. In addition, from a robustness and keeping your system operating, very robust from that perspective. And all three are great stewards of space. So as we move towards wrapping up at least this portion, why automate? Well, back in the early 2000s, was some market research done on supply chain effectiveness, and companies, surprise, surprise, with exceptional order fulfillment, were more profitable, but then they also grew their sales faster. Predictability is really fundamental to exceptional order fulfillment, and automation assures predictability, and that, of course, leads to happy customers. So a quote that I'll attribute to myself, that feeding the world is vital to sustaining a planet. So many of you in supply chain are in the food and beverage space, and that's really your first and foremost, right? When we think about people, profit, and planet, and then ultimately across the board, let's be effective in the use of our people, let's be effective in the use of our space, and keep our customers as happy as possible. And at this point now, we're going to go to questions. And let me make this window here a little bigger. So, let's see. So let's see. One of the questions here is, in this discussion, we looked at only fixed automations. Let's see. And click on there. Come on. The computer is not cooperating. Okay, well, I guess I'm just going to read the questions out loud. I wanted to send them to the screen to share them with everybody, but the computer isn't actually doing what it's supposed to. So we'll just read it out loud. It says here, you mentioned fixed automation solutions for automating storage. Are automated guided vehicles a viable choice as what for the same function? And absolutely, a number of uh, different AGV applications that we've put into cold environments. Uh, the you won't get quite as much density in an automated guided vehicle application as you might get in a traditional ASRs, largely because you can't go as high. You can go to a deep plane kind of configuration with an AGV, but you're a little bit more limited from a granularity perspective. But yeah, certainly it's a viable choice. Um, let's see. So another question that's here is temperature. What's the lowest temperature that the mechatronics are designed to operate in? Well, I'll answer that in a couple of ways. So if we look at what we'll consider the standard, minus 20F is the norm that we'll consider there. There are instances where we have provided automation at lower temperatures, but that is more on a one-off kind of basis. Um, so, guys, I see another question above this as well, all the systems work at just at minus 30 in it. Yeah, it is just some. So I see that question there. And so now on the top side of a frozen or chilled environment, you've got that nasty little 34 to 28 degree range. And are there any challenges in applying automation in that temperature range? And yeah, automation is very applicable. Those that operate in the protein space probably will see that quite frequently. That's pretty common a temperature range for protein. But there are some considerations. It's important to make sure that your space doesn't have a high humidity because that can certainly give you some problems at that temperature because humidity can exist pretty easily in that temperature range. And getting ice on things isn't necessarily good. You certainly want to make sure that you have dry air. But then also if you've got a deep freeze area close by, it's advisable to have some sort of airlock or something along those lines in between the two different spaces, because otherwise that really cold, dry air reaches some air that's got a little bit more humidity, and that could cause some real challenges. So let's see. And so I see another question here. Can we do accumulation within? Oh yeah. So accumulation is quite common within the frozen environments. We have a couple strategies to be able to do that. One of which is to use what we call motorized roller conveyor. So that avoids air altogether. Or as I mentioned just a moment ago, as long as the air is dry, we can use pneumatics within within a system. Okay, another question. In a freezer, is there a min or max weight or specific dimensions that can be handled by automation? And the temperature by itself doesn't have a real impact on the size or weight of the products that can be handled. They certainly can. It's really more the mechatronics itself that becomes the biggest limiting factor. And as I look at the time, I think that we're close to the end. So at this point, I want to sincerely thank everybody for attending. And I see one more question that popped up here that just popped in a moment ago that talked about max speeds of loads that we can handle. Well, that's a big loaded question, and that really is going to vary on which technologies we employ. So there isn't going to be a simple answer to so many cases per minute or so many pallets per hour. It's quite variable based upon how much I'll use the word horsepower that gets applied to, and I don't mean at motor horsepower, but just how much automation gets applied. But we can see some very high speeds in that regard. And I thank one and all. If you have further questions, please feel free to reach out to Dematic, and we'll help you any way we can. Thanks again, everybody. Bye-bye.